All right, so where we were with our last tutorial, we were basically everything except this brake caliper over here. And let me hide this sketch as well. I just added this brake caliper by making a sketch which was this shape over here, and then I revolved it for part of the angle. In fact, I should have the revolve tool down here. When I did my revolve, I chose two sides and I did a little bit up and a little bit down, and I revolved around this over here. That got me that shape. Then for the text, I went to, for the text I did, let me unhide it. For the text, I went to this sketch over here, and in this sketch over here, I made a line. That's this curve over here, and I went to create text, and when I made the text, I chose the option to follow the spline, which is this one over here. So follow the path, and that's how the Nismo does the curve, and I just picked the font and size and stuff like that. And then I just extruded that in to make a cut, 1 millimeter, just so, finish sketch please, just so it would have some sort of indentation. So hopefully when we do our rendering, we can get some 3D shadows to make it look more realistic. Let me hide this sketch because we don't need this sketch anymore. So before we start to render this, if we render this right now, it's going to look kind of trash because it is all one material. But we go to the render tool. I believe I have to save first, save. If I go and render this, I press the render button. Let's just do local render and low quality for now, just so we can actually do this in a reasonable amount of time. And we press that render button. Just confirm, yep, cool. If we click over here, the job is still finishing, but there's our render. It doesn't look terrible, but it definitely, everything is by default steel in Fusion 360. I think you might be able to change that, but basically if you see the grey shapes that most of your bodies are made out of, they're mostly steel. And for some of the brake, that's fine, but we can get some better coloration if we pick something different. So, and then I believe you can zoom in. I think if you minimize, don't freeze up on me again, please. It shouldn't. If you zoom in, you can get better detail. So if we, we don't want to move you, thank you. If we zoom in like here, we can do the same thing. We can go to render. You have the option of cloud rendering or local rendering, where cloud uses their Fusion 360's servers. If you have a student account, so if I click cloud rendering, it should say how many credits are required. 0, cool, because it's a very small render. If you have a more complicated render, it's going to take more credits, 1 credit. If you're on your student account, I believe you get unlimited credits. But if you're doing it on like a hobby license or whatever, you may have to pay for that rendering. This is useful if you have a laptop, because you will really burn out your laptop's battery and wear it out if you keep doing renders. So when you're doing your big renders for projects, use cloud rendering, or if you have access to a desktop, I mean, you can just do it on that and leave it overnight. To do it on your own computer, you press the local render. Again, you pick your detail. I'm just going to pick standard because, we can do excellent. We can just do standard because we have a very simple design for now. But again, final design of a big project, choose a final or an excellent render. It just takes more time, and they do like more light bounces and a higher resolution. If we zoom in there with the local rendering, open up this tab over here, we can see the renderings happening. And I believe this one took longer because we're at closer. So the actual rendering process is it tries to map as the light is reflecting off an object, it bounces in all directions, and then it calculates that light going off another object. It's ray tracing, but not like the RTX graphics cards that you see from NVIDIA. So we can see there we have the Nismo sign over there. We have our brake calipers, we have our holes. Our bolts and our shafts connection thing there, they're all steel, so we don't get great detail down here. So let's change some of that. Let's go back to design. Let's change some of our, so notice things like these lines don't show up. That's because if we go to our display settings, visual style, we currently by default have shaded with visible edges only. If we change it to shaded, that's more visually representing what we would see. but I like to keep with visible edges only so you can actually see where like joints are happening. So let's change some of these things. This, zoom out please. All right, so let's start by, if we right click this, I think you can right click the body and then press, so I just right click it, right click, appearance, and over here we have appearance. You have bodies and components or faces. If you just press faces, I can just change the color or the appearance of that single shape there. If I do the whole body, we can do the entire body of that disk. Yeah.
You can do this in render as well.
You can do it in render? Ah, okay. So you can do that. I usually do it by here, but if you do it by render, do it by render. So for this sake, let's just go body over here. We want, actually I'm fine with this disk actually being steel. Satin steel is fine for us. Let's deal with some other components. Let's say this brake caliper over here, we want to right click this. Let's make this a different material. I want this to be, so all I did is clicked it and I scrolled down. We want it to be a metal. We want it to be we also want it to be a steel, but we want it to be a darker steel. So let's go and say cast, let's make it cast steel. So if I click cast steel, I can click and drag it over the components and it should all change to cast steel. So it's already got a different color. Now let's say this is a high performance vehicle. Let's say we make our bolts are out of polished titanium. We can do that. We can either drag over a single bolt and do that, or if we found all our components, we could, I believe you can press 1. So right now, I am holding the control button. I think you can do this. There you go. So now you can drag them and all the bolts are titanium. Sorry, yeah, those are the screws, these are the bolts. And I'll do the same thing with the bolts because we want them to look cool. Actually, just for fun, let's make these bolts, these aren't polished bolts for whatever reason. So we can see the difference. And this Nismo, let's make this aluminium. Oh, aluminium. Oh, glossy red. Let's get a nice stylish aluminium brake. So now we have all this here. We'll save this again. Yep, cool. Go to design and we'll go to render. And so now we're starting to get some cool colors here. Let's so let's pick a good orientation. Let's say we do it like this. Right. So like that. Let's render. So by default, if you have your image size custom, this is the resolution, 1280 by 15598. That is the resolution of the screen that you're on right now, right? Removing space because you have your top bar and your bottom bar. So that's why the width is 1280. This monitor is 1280 by 720, I think. I don't know what the actual resolution of this monitor is, but it's 1280 by width. And it will by default do that render. While that render is actually happening, right, while it's loading up, you can do another. You can line up multiple renders. So you can also change this image size over here to, let's say we want to make it not video. Let's say we want it to do that one, 1280 by 1024. We click that. Aspect ratios, we can exposure natives, our file type, we can do PNG is the largest file, oh sorry, TIFF is the largest file, PNG is the second largest, and JPEG I believe is the smallest version. I don't know what that transparent background does. I think it's if you're going to paste it into like a photoshopping, by default it puts like an alpha layer at the back that gives it to be transparent. Not really relevant for us. Let's go render. And so while you can actually load up multiple renders here, so if you're going to leave your computer on overnight or whatever to do a whole bunch of renders, and each render takes an hour, you can put them in the queue and then it'll automatically render the next job after that. So when you do custom resolution, it will do it by whichever direction your screen is at, and it'll try to maximize it. All right, we're getting some decent color there. Notice that reflection you get over there. That's like due to ray tracing. It's getting the red light is reflecting off the bright aluminium. But when you do the resolution that you pick, it tries to put the object into the center. So you just got to be careful with your orientation and your zoom level. I would do a standard render first, just to see what the direction would look like. And then once you're good, don't change any settings and just redo it in higher quality resolution. Move the bag. Thank you. All right, so that's the rendering there. You can also add emissive, so lights. So let's say this brake is getting really, really hot because this is brake calipers. Let's say this is a weird design where these brake calipers, for whatever reason, they're getting red hot. Realistically, it's the, yeah, okay, I'll make this red hot. So we have the steel over here. We can actually change this to right-click appearance. And then let's say we have our steel over here, which is our default steel, right? I believe that's our steel Saturn. We'll right-click, we'll duplicate it. And this one over here, we will rename this. So double-click it. We want to say steel, let's say hot. All right, let's give our steel hot a color. So we're going to say our steel hot is going to be somewhere around there. And we can press advanced and we can actually where are our options to make it emissive? No, not cut out, not relief. Right, so not at that option, cancel, delete. We'll go to miscellaneous, not miscellaneous, other, where we should have emissive, not other emissive, miscellaneous, there I am. So in miscellaneous we have emissive. In emissive we have all these colored like LED lights. Let's pick LED red. Right, this is going to be like if it was on a computer. Right. So it's a bit ridiculous right now, but what we can do is we can right-click, we'll duplicate this, because I don't want to ruin the original element. So right-click, edit this LED. Let's say steel red glow. Steel hot, done. And steel hot, let's attach this to there. And then we can right click edit. We'll change the color to, well, what would a hot one be? It would be almost like a, it'll almost be a color like that. And let's change this emissiveness to, 10,000, done. So let's see what this is going to look like. This is like a brake is getting red hot. Let's save this, save, and then let's go to render. So now we're getting a red hot brake. You know, let's just pretend like this is going to work. So I want to really get in there so we can see some reflections. Then if we render it, let's see what this is going to look like. Render. It actually looks like it's getting red hot. And so you'd have to play around with like the, you can already start to see the light glowing off it, and so it should be glowing off all the other parts. This is probably too hot, but that's just because I changed the value of the luminescence coming out from the brake, coming out from that particular color. Okay, so you see here the brake is getting really hot. You can see that it's glowing inside the brake tube there, but it's also reflecting the light on all parts of your, so the disc brake is getting really hot and it's reflecting onto all other parts, like the bolts and the aluminium, the shaft that's connected to the brake. You can also use those other emissive objects to make lights if you're doing like a car with headlights. And you can actually put another object in front of it. You can put, what can you put in front of it? You can have emissive stuff, which is like your lights, right? But then you can also put in front of your emissive, you can put, there's one that's semi-emissive. I'm just trying to find it. Ah, yes, your plastics, under your plastics you have opaque, which is like semi-transparent, right? It's like a diffuser in front of like a light source. When you made those lamps, for example, how you had those plastic in front of it to diffuse the light, so you can use that. Also useful if you have like a bright light and you want to spread over a certain object. All right, so that is when it comes down to the rendering, and obviously the more complicated your design is, the more you can do with your rendering. Let's go back to design now. This is not metal, so let me just change this for now. I want to get back to appearance, please. Right click. No, not repeat. Right click. Appearance. Did I lose the appearance tab probably? Oh, it's over here. Appearance. Let's just make this steel for now, just so we can get back to the whole body, please. Remove. Okay. Let's just make it a standard material for now, and I believe everything else is aluminium. Let's go and check our materials. So this body over here, I believe we can right click. Let's look at our individual components. This over here, which is our disc, we want to right click this disc and make it a physical material. We want to make this is going to be steel. We want this to be, what else do we want? We want metals. So right now in physical material, it doesn't care as much about the color. In fact, it shouldn't be affecting the colors of the design. It is just giving it materials for when we start doing a simulation, which is the next task we're going to do. So it's aluminium. Let's say iron. No, we don't want iron. Ooh. Let's say we want this to be a different steel over here. I'm okay with our bolts to be steel. Right. So we have our disc brake over here. Notice how I put the material, it didn't change the color because appearance goes on top of a material. You can make an object that's made out of metal. The material could be metal, but the appearance could be plastic. So it could be like a coating on the outside, which has very limited mechanical properties. The coating doesn't really affect it if the main of it is steel. So we have our design over here, and again, let's just save it. Then let's go to design, and let's go to simulate. Simulation. If our brake shows up here at all. Okay. Simulation, once you get to the simulation menu, you should have a bunch of these studies over here. Let's just do the very basic study over here, where we're going to static stress, create a study. All right, we have our Nismo thing here, and I believe in the study it gets rid of appearances. This over here is aluminium and everything else is steel for our design. In our study, if we click the materials, study material, it loads up all our components. So depending on as your thing gets more and more complicated, actually naming your components is going to make your life a lot easier. But over here we have everything is steel. We picked one particular name of steel for, I believe that's the shaft, and aluminium is the case of the brakes. You can actually change the individual. So say if this component over here, aluminium was the brake caliper case, you can actually change it over here. You can pick a different material. So if you didn't want aluminium, say you wanted to make it out of copper, you could press that. So you can change a material in your design and see what happens. But let's just go back to same as model. We'll leave the model for now. Okay, so setting up a simulation. We start by checking our materials. We check our constraints. Our constraints is what is not going to change with our model. All right, the one thing that is not going to change with our model, let's say structural constraint, we want this brake caliper. I don't want this to move. I just want to keep that locked in. And then, so everything of the design is going to be with relative to the brake caliper, right? Because this face over here is not going to move. Then let's give this a load. Let's give it a structural load. We are going to try to rotate this middle tube over here, which that's where the wheel is. The type of thing we're going to give it, let's give it a moment. So the wheel's spinning. How many moments do we want? Let's say, do we have to pick the direction? Let's just go 1,000 Newton meters. And the reference we want is with reference to that face. Yep. And so you see the image over here, see that little image of the moment rotating there, which makes sense. It's how our wheel will be rotating. And we press OK. So we have that little moment in there. No, is that not working? No, hold on. I think I messed that up. No, not this. Load case. Let's check our loads over here. This moment, I think I want to adjust this, right click, edit, structural load. I think I want to change this from a face to vectors. So let's say X is the one we want to move. We want X to be 1,000 Newton meters, because that's our X axis, and we want everything else to be 0. Hopefully you know what vectors are. But yes, it's basically, this is the X, Y, and Z axis. So we want it to rotate about the X, we want it to rotate about the X axis. 100 Newton meters, okay. That should be correct. Why is the image going off in that direction? MX, yes. Target is that face, moment. Or do I say normal? No, normal's not going to work. Normal's a single direction. We'll see if this works. If this works, great. So that's our loads. Then we have our contacts. Because we have multiple parts here, we got to, let's just press automatic contacts. Anytime there's a solid that's within 0.1 millimeter of another solid, that's what I'm choosing here, it's going to assume that those points are touching. So it's going to be available for our model. And I think I made sure that everything was touching. Our screws were touching, our bolts, our other parts. We make the contacts. Once this finishes, we can confirm it by looking and seeing how many contacts we have in our model. Are you done? Do I have to actually press cancel? That's no. Finish, please. Well, that's weird. So we've got this. If we go down here and we look at manage contacts, we can see all these bondings are just, that's like two surfaces touching each other. So like the bolts touching the disc, or the bolt touching the shaft, yeah, all that stuff. If we want it to be specific, there's some things that we would want to take off. Like if we want to find the bonding between, like technically, if we wanted the bonding between this face over here and this face over here, we don't want that to be bonded. But for this example, let's just do it. We'll just pretend it's there anyway. We can be more accurate another time. So we have that, and then that's our contacts. We don't talk about a display. We have enough to run the test, so what we do is we go to solve. We do a pre-check. A pre-check says that our study has all the information required, right? The TLDR, usually your study, you always have to make sure you have materials. So you have to always have materials. You have to have a constraint. So you have to have a constraint like your reference point. Because if you don't have enough, if you don't have a constraint locking it in the XYZ, it has infinite calculations. So it's like if you have an object, and before you put force on the object, if it can be anywhere in the room, your computer can't calculate that. Then you have your loads. If you don't have any loads at all, everything is going to be 0. So you solve that. And then if you have parts, if a single part isn't connected to another part, it's going to cause a problem. That's why everything has to be connected. So in theory, we have everything. So we're going to go to solve. Solve over here. We should open up the same solving menu as before, where we have on cloud or locally. For this one, I will do this on cloud, and then I'll pause the recording. Yes. So, why are you not letting me do this? Okay, maybe I have to do it locally. All right, never mind. Maybe I don't have cloud credits on this account. Let's go to solve, and while this is solving, I will pause the stream. All right, so we've finished I paused it and unpaused it now. We see here that the brake explosion drawing simulation locally is complete. So we press close. Do we have anything? Okay, so by default, it's going to do factor of safety. Now, we have a part here that is like thicknesses of aluminium and metal, so it should easily be able to handle 1,000 Newton meters torque. So we have a factor of safety that's like more than 15. And we will learn what factor of safety is. We'll learn it when we do the aerospace or transportation unit. But let's look at something else instead of factor of safety. Let's look at stress. Oh, we got some nice colors here now. So if we do our stress here, we can see that the maximum stress we get is 0.3551 max. I believe this is, and it actually shows the location, 0.3551 megapascals is the maximum stress, and it is right here. Right here, right? So let's talk about, from an engineering standpoint, what this means. This is the part of the wheel that generates the most stress, right? Right here. So what would be the likely case if this brake, if we scaled up the newtons to like 10,000 Newton meters, 100,000 Newton meters, right? The location will probably still be the same. It will probably still be in the same location, except this, instead of being 0.35 megapascals, is going to be 3.5 megapascals, or 35 megapascals, or 350 megapascals. Do you remember what the ultimate tensile stress of the tools you were doing on the tests? What were they? Like 100 megapascals?
125.
Yeah, 125. So once this number over here gets more than 125, this should fail over here. Right? So let's say you're dealing with a case where you're right on the edge, you're close to its maximum strength. This is where a crack would generate. So if we were testing on an aircraft or on a vehicle during warranty, we would check this part over here on the wheel for cracks, because that's where the cracks will be starting. So it really saves us in like a maintenance team. We know where to check. In this example, this isn't moving, but if it was, so it could be in any of these corners, because as it's rotating around the disc, we could find that that's where the stress would happen. Then we also find the place that has the least pressure, which is, I don't know where the minimum is. It's somewhere over here. The bolts. Okay, of course the bolt over there has the least. But you could also find, say, this face over here. We have a lot of place over here that isn't using any pressure, isn't using any stress. So we could remove material from that. Most of the aluminium over here isn't using any, so we could also remove the material from that. That's what we can learn, and that's what we did a test there for free, basically. Apart from the fact we used an educational license. If you're a company, if you're Nismo testing your brake system, you can buy this software, even if it's like $10,000 or $100,000, and you can test thousands of brakes without having to actually make them, buy a testing machine, hire scientists to get out those test samples, and then visibly seeing them with a microscope to see where the cracks started failing. You could test your designs relatively instantly in comparison. Even though I paused it was only like 2 minutes, 2-3 minutes, and the design was done. You can also change your complexity, or you can do other scenarios. You can even do like thermal analysis. As I said, the HSC is not going to include show me how to do a solving function on CAD. But what I have done is we've shown 2 end products from 3 technically. We've done the technical drawing, so you can send it to your supplier, done the rendering, so you can do it for communication, or simulation. These are tools that CAD software have given engineers to improve their design, and it allows for safety for the consumer, because when I drive my i30 and I slam on the brakes because there's somebody who's jumped on the road with trying to catch a ball, I know that because my brakes have been tested or been inspected by this location over here, and they've inspected to see that no cracks have formed in this particular location over here, I have the safety to know that when I slam on my brakes, I'm not going to run into somebody, right? It's not going to snap and cause the whole thing to fail because they've done this testing. That's it for this particular tutorial. You can actually have multiple load cases loaded up. Just before I finish, you can have multiple load cases loaded up, and the same thing as with the renderings, you can have under the solving, you can have like 10 different solvings happening, and it'll do one at a time. So then you can log in the next day and you can see your designs. You can show things such as load case. You can show factor of safety, stress, displacement. You can see how it's rotated, and the actual movement is under the deformation. They adjust it for to give you a visual representation. You can also just make it the actual, which it doesn't actually rotate much. The most movement is that's like 0.00003 of a millimeter, and it makes sense that this part should move more because that tube is rotating and this is locked in. So you're always going to get the least movement where your reference point is. That could be, again, referencing if you do something like an aeroplane where the wings are going to move up and down. What else can you change? You can do reaction force, because if we have newtons, it shows where that of course should be where the most reaction force is. So this is where you can start simulating your bridges or your towers. When we do the structural truss analysis next in Year 12, I'll pop up some simulations to show you, based on our hand calculations, what real, well, quote unquote, real truss analysis looks like. What else can you do? You can do strain, which this puts into, strain I believe is using, well, we know what stress over strain is. Strain is like the movement relative, right, to the original size. And then contact pressure. I forgot what that means. Oh, there you go. Contact pressure is like the joints that we're touching. How much? So contact pressure would be useful if you're doing stuff like glue, because you know where the most pressure happens. Well, the most pressure should happen where the brakes are, but and also where the bolts are. But if you have a certain joint and you have a contact pressure of a certain megapascals, you might need to know maybe glue isn't sufficient. We might have to weld that part. So you can change your adjustments for that. Or if you're doing a braking system, you know that is too much. We need to generate more friction or whatever for that point. All right, I'm going to end this tutorial here. Good luck.